So we're talking composite functions. Now, to get into composite functions, you really need to talk about what makes a function, and even more specifically, this idea of function notation, okay? So when we look at this function notation stuff, the letter in front is your function name. We can use different letters to denote different functions, and I'll have to write them out. But the important part of this is there's an input in here that we usually designated as x. If you plug in x into any equation, do the math, it gives you an output that is a y. So when you look at this idea of this function notation, okay? If I have f of x equals 2x plus 1, when I write this in here, say I wanted to figure out what all of these things are equal to. So f of 2. What this says is I want to take this 2 and I want to replace x where it is. We've done this. You guys know how to do these things. So we go 2 times 2 minus 1, and you would get 3, right? -1 you'd plug in, the 7 you'd plug in, and we get actual numeric answers out of these things, okay? Now, the reason this is called a function, just as a little extra tidbit, what happens with functions is that every input gives you a single output. That's what makes a function, okay? And we've talked about functions a lot in our math education, right? But I wanted you to think about why this makes sense when you look at an equation. If I plug 2 into that equation, f of x, 3 separate times, am I ever going to get a different answer than 3? Like if I go 2 times 2 minus 1, is it always going to be 3? 2 times 2 minus 1 is always going to be 3, right? It doesn't matter. I'm saying if you plugged in your calculator repeatedly, your calculator is not all of a sudden going to go, oh, that's 5. 2 times 2 minus 1 is always going to be 3. And when you think function, we did it a lot with graphs, okay, and tables. But if you think about it as an equation, it makes sense because it doesn't matter what x I plug in. It's always going to give me the same answer by applying those operations, okay? So what happens is every input is always tied to one output. That's what makes a function a function. Our focus is more on this idea of function notation, okay? Because we're to the point to where we're going to have functions that are going to be defined like f of x equals some equation. And what we're going to do when we compose them is it looks very similar to what we did here, where we plugged in 2 and we found an answer of 3, or we plugged in -1 and found the answer of -3. Only distinct difference is instead of having a number as n, where did it go? Error in real time. As an input, we have another function. So for example, when we did this, and this has this special notation with this, either this little circle g of f of x or g of f of x, what happens is instead of plugging a number into the function, we're actually going to plug another function into our function, meaning you'd put the number through f and then you'd put the result through g. So what that would look like in an example. We've got two functions here. F of x is 3x plus 2 and g of x is x plus 5. I'm going to find f of g of x. So what this says is the function f of x, the input is g of x, and g of x is x plus 5. So what happens here when I find the f of x plus 5 is this x becomes a x plus 5. So I get 3 times x plus 5 plus 2. Then we would simplify and we get this new function that is f of g of x. So instead of plugging a number in as your input, we're now plugging a function in as our input. And there's a payoff later on at the end of this that helps us do some specific tasks, okay? Can I get it? Well, let's look at a couple more examples. First off with this, I want to talk about the notation, okay? And I've included the one with the little circle here more than anything. but the order of this is going to matter. And I'm going to show you that with this first one, okay? So what I'm asking you to find with the first one, I want to know f of g of 3. This is f of g of 3. We need to figure out, whoops, that's blue. We need to figure out what this number here is, and then plug that into f of x numerically. So when we go through and we do this, remember that the order you see with the little circle matches what you would see here, meaning you got to do g first, and then plug that answer into f. So as we work down with this, the first part is finding that g of 3. So g of 3, g is x squared, you'd plug in 3 and we would get 9. So this is now the number 9. And all this problem really asked us was to find the value of f if we inputted 9. So we put 9 into that. And we get an answer of 22. Now the reason you need to be careful with this, and we'll practice this here. Let's do this the other way. Let's say we mix this up and we did g of f of x. Am I going to get the same answer? Because that's really the important part here. Does it matter what order I compose these things in? Well, let's look at this right now. So I'm sorry, I put x in there, but we're going to do 3. G of f of 3. So we need to find f of 3 first. So f is this one. So over here, let's find f of 3. So we're going to plug the 3 in here. So that's going to be 3 times 3 minus 5. So that is 3 times 3 is 9. 9 minus 5 is 4. So that f of 3 is really 4. So this problem asked me to find g of 4. So that means we're going to plug 4 into this. We get 4 squared, which is 16. So that means g of f of x is equal to 16. Is that the same thing that I got here? So the order in which you compose these things does matter. You're going to get different results out of it unless they have a special relationship that we'll talk about later on. Okay? So do be cautious with the order that you look at this. If you're ever given the circle, this is the inside one. This is the outside one. I recommend before you do anything, writing this like this because I think this is more telling as you plug things in. So real quick, take a minute, find the answers to these next two. I think so. All right, so again, if you're ever given this notation, my personal preference with it is that I don't like this notation. I like that one because it just clicks in my brain a little bit better. Hey, find g of 10, then plug it into f. So I always rewrite these things first. So we've got to find g of 10, so we're going to plug 10 into here. So that's 10 minus 9, and we get the square root of 1, which is 1. So that means that this 1 is going to get plugged in here for our x when we find f of 1. We should have got negative 18. Yeah, awesome. Same pattern, so g of 12 first. And so that means we're going to plug 12 in here. 12 minus 8 is 4. Square root of 4 is 2. And then we're going to plug 2 in. And we got negative 6. So there's our final answers right down here. So with numbers, this isn't too bad. I don't think this is I think you guys can handle this. You've worked with function notation a little while, okay? Just make sure you break it down into pieces and take your time. Now, let's say we want to take this one step further and we want to actually find the composed function, because what this is saying is, to get to this answer, this is what f of g of 10 would equal. If I take these two functions without plugging in a number and compose them, I can get a new function that will directly give me that answer. And it works very, very much the same way. So I want to find the function that will output all those answers. I want to know what f of g of x is going to be, but I want to write it as its own function. So what we're going to do is, when we look at this, this is what we want to find. So this is where we start. We know we want f of the g of x function. What is g of x equal to? G of x is equal to x to the fourth. You think that's what we had done with the number. We took whatever number had been in here, this had been this, we would have taken that number to the fourth and then plugged that answer in. So that means that in my f function, this x really isn't x anymore, it's x to the fourth. So I substitute that in for every part of that. And then I simplify anything that would need to be simplified. The 9 isn't going to get taken to the fourth because there was no parentheses around that or anything. So that means that my new function is this. Now, the reason that you would want to look at this, right? Let's say we wanted f of g of 1, because I can do 1 pretty quickly. If we plug this in for 1, let's do this the way we did on the last slide. 1 to the fourth means that we really want f of 1, right? So now to find f of 1, we would plug in the 1, and we get -9 times 1 plus 3, which is -6, right? What happens is with this new composed function, which is this is what happens if I just use the x instead of the number. That means I can plug 1 directly into this. And lo and behold, it's going to give me the same answer. Meaning that let's think about it, if I had multiple of these that I needed to compute, finding the function itself means that I can directly find those answers much quicker than having to do it in 2 parts, okay? So that's where the idea of the function is. We're actually using it's a more difficult function, but we're breaking it into pieces that are simpler as we work through. So try these two. See if you can find the function for f of g of x for both of these. So same scratch sheet. Here you're writing a function because the answer that I looked for in this first one was this. That's what we wanted to do. So we understand this part right away. So we know that we want f of g of x. So we got to take this x plus 2 and plug it in wherever we see an x. So we get 2 times x plus 2 minus 5. And the key with this, just be really cautious with your simplifications, okay? Distribute. And then that's our function that gives us f of g of x. And we could plug in any x straight into that, figure out what the output from both functions would be. This one, it works the same way. So we're going to plug g of x in here. So that x minus 3 goes in. And here we get these parentheses. That means we've got to square this. It means you got to draw the box and multiply that thing out, which will give us the x squared minus 6x plus 9. And then combine these two. And this is our function for f of g of x. So our answer is right here at the end. So really when we're combining these, we're taking two functions and we're combining them. We're actually making a new function out of it, okay? So let's look at some different representations we might need to deal with when we work through this, okay? I'm sorry, I was talking about the wrong slide. Let's try to work this the other direction, and we're going to spend more time on this later. So what this says is if we have h of x, I'm giving you h of x. H of x is the composition function, so meaning it's where we stopped over here. And then it tells me that h of x is made of two functions, f of g of x. So I know that this h of x is made up of f of g of x. Now what is nice here is that they give me one of these functions, and what we want to find out is what is the other one. So they're giving me the outside part. They want to know what is the inside part. So let's see if we can dissect that. I'm going to write this bigger over here. So we have h of x equals 2x minus 5 squared. And we know that h of x is f of some g of x. And the one we want to figure out is the g of x. F of x is x squared, so it's almost like substitution. If I were to write this with just the squared, and I'm not going to use an x here, I'm going to use an a. This is our function f of x. This is what happens afterwards. We need to figure out, well, what function g of x went into this thing? So what part, if we match these up, does g of x have to be? It has to be for this one, that stuff that's inside the parentheses, because afterwards our after function was squared. That part kind of goes away. That's just our x squared. The function that went into this had to be this 2x minus 5. These take a little bit more dissecting. There's not going to be necessarily always one direct way to get to these every time. You're going to have to kind of list this out and work through each one. How could you check your work though? Well, if you figured this was g of x and I gave you f of x, you could go backwards and you could go this direction and compose these things and find the actual function as we go through. So this one's going to take a little bit more practice. So tell me what g of x is for our last two, okay? Try that yourselves, and then we'll check and see where we're at. All right, I'm going to talk about these ones, okay? Now these are real specific, and we are going to spend more time with the idea of this is called decomposing a function. Now, we spend more time as we talk through this unit about this. But what the important part of this is that we're told that h of x is f of g of x, and we're given f. So what we really need to figure out is what's the extra stuff with the x that's in my function. So I know that f of x, which is the outside function, is the square root. And the x that the number that gets plugged in for it is in here. I'm going to put an a right in there because the second function that I have for g of x has to be everything that's inside that square root, because g of x goes into f of x when I go to find this. So that's why g of x is x plus 5. It's what's trapped inside that square root symbol. We come down here and we look at number 3. This one looks real complex, okay? But we're told that f of x is x squared minus x. Now, we know that g of x is going to replace, there's a function that's going to replace that x. So I'm going to change its variable just so it looks different. I know that it's got to be a squared minus a, and the function that I'm hunting for is whatever a is. Well, we see the squared and the single, and notice that these two things match, right? Those two things are the function that got plugged into it. If I took those away, then I would have x squared minus x, which is what I know f of x has to be. So therefore, G has to be this stuff that appeared inside the parentheses that replaced the X. Almost like you can match them up and try to figure out, okay, what stuff got plugged in here, and it has to be the same for each time I see the X. And that's why that one is G of f of X. And you can always go back. So you said this was G, so actually find G of f of X. So that's f of 5x plus 1. Since f was x squared minus x, this would end up being 5x plus 1 squared minus 5x plus 1. Now notice I didn't simplify it before I did it for you to find the composite here, because you would keep going as you found the composite function and simplify that further. But we were trying to lead to the idea that you can still break this down. Okay? So now let's look at a couple of different representations of actually finding the converse. I'm sorry, finding the composite. So some different representations. I took away the equations, and now I gave you graphs. Now remember, graphs, you can still figure out which x corresponds to every y for the function. So the first part of this, f of x is the red graph. G of x is the blue graph. Now I don't know their equations, but that doesn't mean I still can find these answers. So I want to figure out f of g of 2. Well, before I figure out what to plug into f, I need to figure out what g of 2 is. So what this is asking me is, at the x value of 2, what's the output or the y value for the function at g? So I'm going to go out to 2. Here's 2. And I want to figure out where is the graph of g at 2? Well, it hits right here on the axis. At an x of 2, it gives me an output of 0. So that means this can also be written as f of 0. And I want to know the answer to that. So now I need to go at the x equals 0 and figure out where the graph of f is. So here's 0. F is the red graph. So we trace down, and this is our spot right here. So at 0, the output is -3. So the answer to this is -3. It works the same way as figuring out what you're plugging in, but instead of having a nice equation to easily plug numbers into and calculate, we've got to read them off the graph. So let's go through and try this part B. The only reason we have this one up here so we remember the notation. This is f of g of 0. So we need to figure out g of 0. So g at 0 is right here. So that's a y value of -2. So I need to figure out, so the -2 is what I'm plugging into f. So I come back here to -2 when I trace up and find out that f is at +5. So that means the answer to this should be +5. And we continue the same practice with me when reading the graphs every time. So f of 2, g of f of 2. So find f at 2, go out to 2, and we go down, and we find f is at -3. So this is g of -3. So we go out to -3 now. And we have to find g, so we go down, and we see it's at -5 on the y. So that means this is -5 is our output. Lots of tracing, lots of reading graphs, and it's really easy to get confused. Break this down into parts, rewrite it with the number in there so you know what you're going back to hunt, okay? Because with something like this, it's really easy to start just tracing and not writing anything down to find an answer, and you'll find yourself confused real easily sometimes. So g of f of -1. So we've got to find f at -1. So f is the red function. So we go to -1, and we see the y value 0. So this is really asking me g of 0. So at 0, we're going to trace down to g, which is the blue function, which is at -2. So the answer to this composite is really -2. So do these other 4 real fast. Check our work, okay? Just write down the answers, read it off the graph, and we'll double check ourselves in just a second. And then we'll work for this bottom one. Don't worry about the bottom one quite yet. Sorry about number 8, or 8, that's letter G. I clipped the graph a little too short. Because you got f of -6, and -6 is not on the graph, right? I'm not going to make you extrapolate what the equation would be or anything that crazy, as long as I did that one right. Because f of 1 is -4. G at -4 is -6. And then you look at -6, you can't see it on the graph. You should be able to see it on the graph, I'm sorry. There was more to the top of that graph, and I clipped it too short when I put it in our slides. But E and F were where we started. We got 0 and we got -3. Everybody okay with that? On the inside one, and then use that X value to find where it hits in the other one. Whenever you're given more than one, you start with the inside and find the numbers and just work your way out one at a time. This one should have been on the graph. That was an editing error on my part to make it fit on the paper. But let's look at H. So we started with G of 0. So G at 0 was -2. Because G is the blue graph, so we're down here at -2. And then F at -2. So we got out to -2 and we go up to F and we find out it's 5. So G at 5, come over here to 5 and go up, and we got 3. And you could continue to do this process more and more times as big as your graphs are, okay? Any questions before I move on with that one? A lot of this comes down to reading the graphs. The numbers inside the F and G and H or whatever letters you have are going to be X values, and you're hunting to replace them with their Y values on the graph. Oh, we didn't do the last problem, I'm sorry. So for what values of X is F of G of X -3? So when we look at this, we want to know what number do we put in on F to get -3 as an answer. Now remember, the -3 as an answer is a Y value. So that means we got to look at -3 right here. And we've got to figure out when it hits graph F. So it hits graph F in 2 places, here and here, right? So that means that the number that could have gone into this, there were 2 numbers. One of them would have been 0, or we could have gotten +2. So then we need to look back at the function for G and figure out what values would give us 0 and what values would give us 2. And those are still horizontal lines. So let's go up here to 0. So that means that for our function G, it touches it right there. So remember, we're looking input values here, X's, not Y's. We know the Y. Well, Y was 0. The X was +2. The other one we need to look at is when we touch at 2. That means we'd come up here. This is when our G of X function was 2. And the X value that corresponded to that was a +4. So the 2 answers for this, right? For our X values, it would be X equals 2 or 4. It's just working backwards from the Y values and looking back to the X to figure out what went in. Let's wrap all this up and talk about this with all these different types of representations, because what I think we'll end up struggling with the most is we understand the process. We've got to figure out the output that comes out of each function, but we could be given this in in many different representations. So I've given you all three functions, f, g, and h, in different representations. So the table represents f of x. And x is our inputs. These are the outputs. G of x is in the graph, just like we worked with. And h of x is down here in the equation. And from all of these, we need to figure out if we plug this number in, what do we get out? So we can plug that into the next number. So to solve this one, we need to find f at x equals 2. So I've represented f of x with a table. So we need to find the x value of 2. So the x value of 2 corresponds to the 5. So this is really asking me h of 5. Now h has a different representation. H is represented with an equation here, and these are absolute values. So that means I need to take this 5 and plug it into this equation and find its solution. So to find the answer to this one, this would be 2, absolute value of 5 minus 4. So 5 minus 4 is 1. An absolute value just makes whatever result you get inside positive. So since it's already positive, this is going to be 2 times 1. So our solution is 2. So be prepared to work from all of these different representations. Let's do all of these together. So h of g of 3. So g is represented with a graph, but these are still x values. So we're going to come out here to the 3 and go down to our graph to figure out our output, which is -1, because the x value of 3 has an output of -1. So this is h of -1, and h is the equation again. So that means we're going to go 2, -1 minus 4. And now we need to be cautious in here. 2 times the absolute value of -5. The absolute value of -5 is positive, and 2 times 5 would give us a result of 10 for that composite. G of f. So we're going to look at the table first, and then we're going to use the graph. So we want f of -2. So this is our x value. So we find that over here. -2 corresponds to a positive 5. So we'll substitute that in. And we want g of 5. Well, g is the graph, so we'll count out 1, 2, 3, 4, 5. And go up right here. And so that means at 5, we're up at positive 3. So our solution is just 3. And just like the other ones where we did on the graphs, we had more than one function. The same thing works here. We want g of f of h of 3. So since h of 3 is the equation, let's plug that in. 2, absolute value of 3 minus 4. So that's 2 times the absolute value of -1. Remember, absolute value will just make this positive, so that's 2 times 1. So that one's 2. So this simplifies the first step into g of f of 2. So now we need to find so we found the h of 3 first. Now we need to find the f of 2. That's our table again. So there's no math to do here. So we go down in the x column and find the 2. The output was 5, so we'll replace that with a 5. And we want g of 5, which it just so happens I don't even need to erase anything on my graph because that's the one I have. Out at 5, we were up 3, so the solution is 3.